What is 6 degrees of freedom, or 6 DoF for short? 6 DoF refers to the freedom of movement of a rigid body in 3-dimensional space. But anyone can Google 6 DoF and get that definition. What does it actually mean? Put simply, the degrees of freedom refer to the ways our bodies and other objects can move through the space around us. Take the space shuttle, for example. It can move along 3 axes that are commonly referred to as the Cartesian, or X, Y, and Z plane, which you might remember from algebra class. It can move forward or backward on the x-axis, left and right on the y-axis, and up and down on the z-axis. There are, however, 3 more movements the shuttle can make. The shuttle can roll on the x-axis, it can pitch forward or backward on the y-axis, and it can rotate or yaw in a circle on the z-axis. Those are the 6 basic movements, or degrees of freedom, that any object can make. But not every object can move in all 6 degrees. Fingers, for example, can't move independently of the hand in the X, Y, and Z planes, but they do have pitch, roll, and yaw capabilities. So if there are only 6 degrees of freedom, how can we see robots that have 20 or more degrees of freedom? Each moving part or joint on the robot has up to 6 DoF. Returning to fingers, each one has 3 degrees of freedom, as do wrists, elbows, and shoulders. Our hips, knees, ankles, toes, necks, even ears have their own degrees of freedom, and they all add up. And in manufacturing, each joint and the 6 potential degrees of freedom that come with it represents a value that must be captured and tracked to ensure accuracy. This makes having a laser tracker that can capture all 6 DoF for the probe or sensor measuring a part essential in today's automated manufacturing environments.